Hello, everyone. Welcome to this Twitch stream on the newly launched Manning Live project, Secure Application Deployment with Istio on Kubernetes. I am Neeraj Poddar. I'm co-founder and chief architect at Aspen Mesh. I've been a long-time maintainer and contributor to the Istio project and currently part of the Istio technical oversight and steering committee. So today, what I'm going to cover is give a brief overview about this project, go into the various sections, talk about the workflow and what you can expect as a user of this project, what are the key takeaways, and then zoom in on one of the sections where I will describe how you can expose multiple domains with unique certificates on a single Istio Ingress gateway. But before we get started, I want to quickly cover why I created this project. So Istio is a very popular open source service mesh platform, which was created in collaboration around 3 years ago, or even 3.5 years ago, in collaboration between Google, Lyft, and IBM. And since then, it has gained tremendous popularity. Service mesh as a technology pattern is being used more and more, and Istio is one of the few predominant players in the market. So as you can imagine, given the popularity of the project, there are various online resources and tutorials and books dedicated to teaching Istio. In spite of that, I decided to create another asset, if you want to call it. And the reason was there were a few key things that were missing in this project. First, most of these resources were dedicated towards teaching Istio without keeping the context of how a particular operator or a SRE does their job day to day. It was difficult for users to take the concepts explained about Istio and bring it back to their daily life and practice, right? So this project is built a little differently. In this live project, I have centered all the Istio concepts around doing some specific tasks related to applications. In particular, the agenda or the overall core of the project is how can I secure my application and how can I securely expose it over the internet to my users. So with that aim in mind, I'm going to go over various Istio concepts and teach you how to achieve that goal with Istio. Additionally, many of the resources focus on the east-west traffic or securing the traffic or using Istio in context of the traffic which flows once the traffic is within your cluster. Often, ingress gateway or the north-south traffic, as we call it, is ignored, which is covered heavily in this live project. Secondly, and more importantly for me, many of these tutorials or the online resources or ebooks, they explain or they cover Istio resources that you need to create to accomplish a task, but they fail to go into the details which are important about each of the fields which are involved in specific Istio resources. And it's important to understand what resources you create or you need to create, but more importantly, you need to understand how this particular resource or a particular Istio custom resource interacts with another one. What happens if you change a particular field? Does it break the traffic or does it make your application insecure? So these are the key things that I had in mind, which I wanted to cover so that some of the gaps that are there in the present resources, plus some of the difficulties which I have observed users have when they're dealing with Istio for the first time are dealt in this live project. More importantly, it's geared towards attaining a specific task, like I was saying. So what that means is after you finish this live project, you can take the learnings, go into your production environment and secure your application by following the same steps. You don't have to learn something in abstract and then try to apply it to your environment, right? So with that background, let's take a quick look at the landing page of this live project on the Manning side. So this is what the landing page looks like. Here it describes the prerequisites and the skills learned. So as I was saying, this project is all about securing your application with Istio, and it is about doing it on Kubernetes. So you need to understand a little bit about Istio. You don't need a lot of information. If you just have some concept of what a service mesh is, then you will be successfully able to complete this project. As I explain a lot about Istio, the sidecar architecture, the service mesh pattern, and then the APIs and how you use those APIs, right? You need an intermediate understanding of Kubernetes so that you can run the various commands and you're comfortable using those commands as you go through this live project. You need a beginner understanding of Prometheus and Jaeger tracing, because I will be explaining how you can use telemetry and tracing to debug your application, again, in the context of securing it and making sure you get your traffic encrypted inside your cluster. And then you need to understand, have a good understanding of how HTTPS and TLS works, because essentially encrypting end user traffic or authorizing it all is building on the basic concepts of TLS. Going forward, you'll be learning a lot of skills, and I hope it is useful for everyone, whoever takes this project. You will be able to understand how you can use a Istio service mesh, how you can expose your application to users securely via HTTPS. You can protect the sensitive user information using Istio authentication and authorization policies. And overall, you have a good understanding of your application behavior by just adding the Istio telemetry or the Istio site or the Istio mesh in your environment. And lastly, which again is one of those things which is often missing in various resources, is how do you debug your service mesh? Because adding Istio service mesh gives you a lot of freedom, sometimes its configuration can be complex to understand. And if you make mistakes in those configuration, you can have downtime. So it's not only important to understand how you can successfully deploy Istio service mesh, use it to expose your applications, but also figure out quickly how to fix things when it breaks, right? And that's what is covered in the last chapter. So with that, I'm gonna go over to the live project. So this is how the project looks like. So the first thing that comes up is a prerequisite test. The prerequisite test is a very simple quiz which asks you some basic questions on Kubernetes and HTTP protocols so that we can level set if this project is good for the skill set that you're coming in. As I said, all the skills needed, all the prerequisites and the level at which they are needed are explained well in the landing page, but adding this quiz just makes it so that you can be rest assured you will be able to successfully complete this project and gain the skills that you came out here to do. So once you click on starting the project, it gives you a good overview about what this live project is about, who is the key audience, right? As you would expect, Istio service mesh is used heavily by the DevOps or the platforms team, whose job is to making sure that the infrastructure is up and running, and they have the right tools in place to have security and observability so that they can protect the data and they can quickly debug issues in their environment. Additionally, it is also useful for developers who are trying to understand how they can offload some of their complex logic from the application into the platform, and also making sure that where the boundary lies between application and infrastructure so that they're not repeating work, right? So that's the key audience here. I think primarily it's geared towards DevOps or platform teams or platform operators, and then it might be useful for developers who want to take this so that they understand more about the infrastructure and the boundaries between application and infrastructure. For the key takeaways, for me, it is that you are learning via this live project, you are learning in a practical way from the ground up how you can deploy an application, secure it and expose it to your users, how you can use the authentication and authorization primitives in Istio to basically protect your sensitive data, all without changing your application code. So that's the key here. As a platform owner or a platform team, if you add Istio and its capabilities, you can enable your developer team to focus more and more on the business logic and worry less about what to do and how to deal with the infrastructure. So these are some of the techniques that will be employed. You'll be installing Istio, you'll be deploying a microservices-based application, and then you'll be learning about how you can expose your application using Istio Ingress Gateway, how you can encrypt the traffic, you can secure your APIs and protect sensitive information using JART authentication tokens, and then use the telemetry and tracing to understand traffic and application behavior. So the project itself is broken into 6 milestones. So the first milestone is all about deploying a microservices-based application on Istio. This is how we are building the foundation. In this chapter, I'll be giving you a brief overview about the Istio architecture. I'll be explaining various Istio APIs, and then you'll be installing Istio in your cluster. So as Kubernetes is required for running this, or for being successfully able to run this live project, I recommend using a Minikube cluster. If you have some other cloud-based cluster or some other environment, anything that is compatible with the version of Istio that you're going to use, it will work. But this project assumes you're running it on Minikube, and the steps are documented based on that. Then moving on, at the end of the first chapter, the idea is you have a running Istio service mesh, and you have an application which is not exposed to the internet, but it is using the Istio service mesh. Secondly, you will be exposing the application on HTTP port. You will be doing that using Istio Ingress Gateway. You will look at the capabilities of Istio Ingress Gateway, where you can route traffic to different versions. That will be covered in chapter 2. In chapter 3, you will be encrypting the end user traffic using the HTTPS capability provided by Istio. You will be using TLS search to do that. And then the focus of this session today is chapter 3.2, where you'll be using Istio Ingress Gateway to expose multiple domains, which each use unique certificates, but you can expose them on the same port on the same gateway. Right? The benefit there is you don't have to spin up another infrastructure, and depending on the type of traffic or the SNI in particular in the TLS handshake the gateway receives, it can offer the right certificates. And then the later chapters here build upon those principles. The fourth one is going to talk about how you can add user authentication. You can protect sensitive information in your requests by adding JAR tokens, so that access to those paths or access to that information is only possible if you present a valid token. So again, you can do that all without changing your applications. Then in the fourth chapter, I'll be also covering how you can add authorization primitives, so you can deny access to certain paths based on either the user information, based on JAR, or based on some other attribute of the request. The fifth chapter is focused on understanding the application behavior in the context of failures or in the context of security, so that you can quickly understand when things are happening in your cluster. So how you can get good telemetry, good metrics out of the box, how you can go to Prometheus and query certain various metrics, and also what's the impact of failures and at various levels. So if the traffic is failing at Istio Ingress Gateway, what kind of metrics are you going to get? What kind of labels are you going to get compared to if the traffic is forwarded to an upstream service? Right? And then in this milestone, I'm also going to cover about Jaeger tracing and how you get tracing out of the box with Istio. But at the same time, you need some cooperation from the application. That is another key thing which is often overlooked when people talk about Istio. In this project, I will focus on that piece. And lastly, you will learn the tools and the skills you will need to debug your mesh. You will understand and you will gain a good overview of the Envoy architecture and the Envoy configuration paradigm, and how Istio is configuring Envoy, and then you can use that Envoy configuration as a single source of truth to debug things in your application. Right? We'll also look at various tools that is available at your disposal as you go along this project. In chapter 6, we are going to particularly talk about Istio CTL tool, which is the recommended tool by the Istio community to get good understanding of your mesh. So this is a very high level overview of what this project is about. And then going a little bit again into the prerequisites, like I was explaining in the landing page, all the prerequisites are again listed here, but in this, there are more details on each of them. For Kubernetes, for example, you need to have a good understanding of various concepts like deployment services and pods. You need to understand pod networking. And similarly, all the things that we expect or that are needed for a user to successfully understand and finish this project are listed here. Another interesting aspect of liveProject is there are various helpful resources, whether it's manning or outside. I have listed, which you can use as reference if you want to go deeper into a section that might be more interesting to you. The good thing is any of the Manning resources that are referenced will be available for you as you're completing the live project, and obviously you can purchase them later if those appeal to you. So with that, what I'm going to do is basically go over here, show you chapter 1, what things are covered here. Then follow the steps listed in chapter 1 to install Istio in my cluster, and then zoom in into the aspect of securing it and exposing it to the outside world using HTTPS, and then serving multiple domains with unique certificates using Istio Ingress Gateway. So let's get started. So the first chapter here, the Istio architecture overview, gives a very high level overview on the Istio architecture and why it's important to this project. Without understanding those foundational pieces, it's very, very difficult to be successful with either deploying Istio or running it in production. The second important thing is the best way to be successful with Istio is to use and start it piecemeal. And that's why the focus of this live project is only to how to successfully expose your application to the outside world using Istio Ingress Gateway, how to secure it, how to debug it in that context. This is, again, one of the things that I've seen a lot of users do when they want to start using Istio. They want to first understand how they can get traffic into their cluster and then use the remaining pieces. So like I was saying, Istio Service Mesh helps manage the communication between microservices. It makes it operationally secure and reliable. There are 3 core capabilities of Istio: traffic management, security, and observability. Most of the online resources and docs that you will find will have the tutorials geared around these 3 pillars. I have taken a different tact here. I'm going to again explain Istio in the context of how you can use it to secure your application. So the key thing about Istio architecture is it's built of 2 key components: the Istio control plane and data plane. Control plane here shown in blue is responsible for configuring the data plane, and the data plane here consists of Envoy proxies. These proxies can be deployed in sidecar proxy architecture that you see here, where service A has the pod A has the sidecar proxy injected in it as another container, or it can be in the form of Ingress Gateway, which we'll cover just in the section below it. The key here is there's a clean delineation in the control plane, the data plane. The control plane is responsible for configuring the data plane, and the data plane is responsible for getting the traffic where it should be going, enforcing policies. The reason this separation exists is you can have independent scalability, and if there are connectivity issues, the data plane continues to function with the last known configuration. The key components of Istio are Envoy. Envoy is the data plane proxy, it's a fast proxy written by Lyft, and it's part of CNCF now. It is in Istio, it is configured to intercept all inbound and outbound traffic by default. And in Istio, it's deployed, like I was saying, in the sidecar model, where all the traffic will be proxied through the Envoy sidecar. Istio daemon is the key control plane element. It has 3 responsibilities. It validates and processes any user provided configuration. It automatically discovers services and workloads from underlying platform. And then it can combine the high-level routing and configuration and configure the Envoy sidecar proxies or the gateways. Basically, it does a translation layer from user-provided configuration, your platform services, everything into Envoy, so you don't have to learn the data plane configuration or the data plane APIs yourself. And then lastly is Istio Ingress Gateway. Ingress Gateway is the key piece that is a focus in this project. And then the job of the Ingress Gateway is to get the traffic from outside of your cluster into the mesh. Right? These proxies or these gateways are a strategic point of control. And in order to have secure traffic and a secure environment, these gateways need to be configured correctly. So once you add the gateway into your environment, this is what the architecture looks like. You have the administrator configuring the Istio resources using Kubernetes APIs. That goes to Istio D is watching the Kubernetes API server and uses it to configure the sidecar proxies. At the same time, if you're using an Istio ingress gateway, the Istio D will also configure the ingress gateway the same way it configures these proxies. There's fundamentally no difference between ingress gateway and Envoy and the sidecar proxies, as they are both Envoy proxies. The only difference is the gateway case, it is configured as a standalone proxy, as there is no application deployed next to it. And all the traffic that coming in from the end user goes over the internet, and it should first hit the ingress gateway, and then it should be routed within your cluster to services within your cluster. So going forward, the next chapter here talks about Istio APIs. Again, this is a very high level overview of Istio APIs. It's important to understand how these APIs are created, what is the main intent, and how you can use them together to unlock the full potential of the mesh. So all the Istio APIs are configured or defined as part of Kubernetes custom resource definitions, or CRDs. So the good thing about it is, if you are a Kubernetes operator and you're familiar with the Kubernetes workflow, you can use the same tools to define Istio resources. You don't have to go and learn yet another configuration management system. This is a quick example of what a Istio resource looks like. If you have been using Kubernetes, you should be very familiar with this configuration structure, as most of these fields look similar other than the spec field, which is specific to each CRD. Don't worry about the resource in the fields here. If you are going to be taking this project, you will get to know a lot about virtual services and what these individual fields will. This here is just an example to show what resources in Istio look like. So these are the key Istio APIs that we'll be using in this project. The first API is Gateway. The Istio Gateway API controls the exposure of services or the traffic at layer 4 or layer 6 for a proxy. In this case, they only control the gateway proxies, whether it's ingress gateway or the egress gateway. And it is used to configure TCP and HTTP traffic, but only at a layer 4 or layer 6. So things like specifying your certificates, your IPs and ports, those belong in the gateways. Virtual services, on the other hand, define the set of traffic rules which will be used to route the traffic to a service based on its host name and other match attributes. You can use the virtual services to specify traffic behavior and define how you'll be routing it. The good thing about having a decoupling between gateway and virtual service is you can have virtual services which can tie to many gateways, and you can use them cleverly to have the flexibility around traffic which can come into your network can be directed using DNS or some other tricks to different gateways, but the routing configuration is defined uniformly. Right? Destination rules define policies for traffic once the routing has happened. So both virtual services and destination rule APIs take effect on the client side. One is used for routing and one is used after the routing has been done. So there's a concrete upstream service that we know that this traffic will be going to. Now you apply the destination rules to understand the connection, to configure the connection parameters of the TLS settings. Request authentication is used to verify the end user identity. Currently, Istio supports JAT or JSON Web Token based validation for end users. We'll be covering this in this topic. The request authentication APIs are covered in lots of details in section 4 of this project. And then authorization policies are used to configure access control. Istio gives you a lot of flexible primitives to define access control policies both at layer 4 and layer 7. And then you can combine things like routing, authentication, and authorization to have a very well-defined rich set of APIs that to all together define where the traffic will go and what traffic will be accepted or rejected. So often when users look at Istio and they look at all the different configuration paradigms, they're often confused as how are these related? Where does one take effect? So this diagram gives you a very high level overview of what happens. So gateways define the listener configuration. They are basically telling you what port a gateway should listen, what ports should match, and then how to terminate the TLS. Once that happens, the next level up is request authentication and authorization. Remember, these three APIs, gateways, request authentication, and authorization, are always on the inbound side. So when you're talking about ingress gateway, this is the side of traffic coming from the end user. So gateways are defining the ports and hosts and also how to terminate TLS. Then the request authentication APIs will verify the user identity and reject the request if the identities don't match on what's expected. Authorization policies enforce access control. Once the inbound chain is completed, the outbound direction traffic is handled. In the outbound side, which is the client side for sidecars, and you can think of it as the client for ingress gateway to basically the virtual services and destination rules are enforced on the outbound side while the gateway acts as a client and makes the request to the services, right? So virtual services decides how to route this traffic, which has already been authorized, authenticated, and then destination rule, once it knows the service, picks the cluster, it defines how to get the service, how to get the request from the gateway to that service, whether to use, what connection settings to use, whether to use TLS or not. So this is again a very quick overview of Istio APIs. So going forward now, we'll be installing Istio in a Kubernetes cluster. Like I was saying, the recommended platform for installing Istio for this project is Minikube. I already have a Minikube cluster set up here. So what I can do is quickly show you, and I have the right number of CPUs. So I can show you how I have installed, what version of Kubernetes I have installed. So if I run this command, it will tell me I have 119.7 and 122. And then the next thing to do is to download and run Istio. I already have Istio 191 downloaded. So I'm gonna just go into my directory. Oops. Oh, looks like I was already in it. So let's see. So I'm gonna go into my Istio 191 directory and then start using the steps mentioned here to install Istio. The key thing here is, again, I'm walking relatively quickly through these steps. When you're taking the project, please read the steps and go through them as they explain some important concepts on why certain things, why these commands work, and what's the layout of the various install packages and what's underneath them. So the quickest way and the recommended way to install Istio is using Istio-CTL, which is what we're going to do here. So I'm going to just copy this line and install Istio in my cluster. Beautiful. So Istio is installed. As you can see, the messages are more or less the same. Then I'm going to quickly verify what has this command done. So by default, Istio will get installed in Istio system namespace. It creates the default version of Istio-CTL, which uses the demo profile, will install Istio-D, the control plane, and Istio Ingress and Istio Egress Gateway. Even though we'll not be using Istio Egress Gateway in this live project, it's just installed, but we'll be using both Istio-D and Istio Ingress Gateway extensively. So far so good. So we have Istio control plane installed, and we have all the components running. So with that, the next thing to do is to understand how I can add my application into how I can add my application to the Kubernetes cluster, and how I can make sure that Istio is bolted on top so that my applications are part of the mesh. So the key to doing that is labeling your namespaces. So a namespace which is labeled with Istio injection equals enabled signals to the Istio control plane that any pods that come up in that cluster, the sidecar proxy has to be injected. So this is what we call automatic sidecar injection, which is the recommended way to run Istio in production. So far so good. So we'll go to the next chapter, in which we'll be deploying the online boutique sample application. This is the chosen application. This is the chosen application in this project, which is a very nice microservices-based demo application created by Google Cloud. It has lots of different services written in different languages. They all communicate with each other to create a online boutique store, which you can use, click around to look at the items and buy certain items, add it to your cart and check out and stuff like that. Quick reference here, if you're not familiar or comfortable with Minikube, here's a reference to a book which you can use to install Minikube. In Mac OS, the installation is pretty simple. You can use a brew command to do that, but if you're using some different OSs or different machines, you might be able to use this book to have a look at how to install Minikube. So let's go on to deploy our sample application. So here is a quick architecture diagram of what the sample application looks like. As you can see, there are lots of different microservices. The traffic comes into the front-end application, and the front-end makes a request to a bunch of different other applications like the checkout service, the product catalog, and the checkout service itself might be calling payment service. So this demo application is a really nice application for us to use, as it has the various elements of a modern architecture or a modern application, and it can help us show the real value of our Istio service mesh. So to deploy this application, we are going to create a new namespace called Online Boutique. I am going to label this namespace with the Istio injection label so that automatic injection is turned on. And then I'm going to download the manifest of the application itself. So there is a liveProject GitHub repo in which I have all the manifests, scripts, and some other helpful things for different milestones. So, and this project is available to you as a reference, so you should use it whenever you can. So this resource is also from from the GitHub project. So we'll do a quick curl command to download it. So with that, I should have an online boutique manifest YAML. If you look into it, it's basically a bunch of different deployment and services for the various microservices that I just showed you in the architecture diagram. So let's apply it in our cluster in the online boutique namespace. Beautiful. So now let's quickly verify if things are working as expected. So if I get the number of pods in the online boutique namespace, I'm seeing that these pods are coming up. The key thing here is you can see there are 2 out of 2 containers in every pod. So one of the containers is belonging to the application container, and the second container is the sidecar proxy container that was added by the control plane. So we'll have to wait until all of these pods are up and running. They should be ready in a few seconds here. And that's what this project explains. And this is what you should do in your production environment, right? So your application is only ready after both of the containers, the application container and the sidecar proxy container is ready. So let's check again. Few of these pods are in the running state. We'll wait until everything gets to that state. All right, we're getting there. So most of them are running. The first two are still not ready. As you can see, 1 out of 2 is ready. We should ideally have 2 out of 2. This pod is crashing, and the reason it crashes is there's a dependency here with the other pods, but that dependency should get resolved once all the pods are up and running. Good. So now everything is in running. The pod that was in crash loop back has come up again, so hopefully it will be ready soon. Let's see. All right, good. So now all of our pods are ready. So we are good to go to the next step, to the next task. So here is a command which you can run to quickly check all the control plane elements and the proxies are running with the right versions that you expect. So if I run istio-ctl version, it tells me all my versions are 191, which is what I would expect since I have installed everything from basically in a fresh environment. But often you might have some old lingering proxies or an old version of control plane. So always good to check what's happening. So with Istio running, what I'm going to do is now expose my application using HTTPS. So I'm going to skip over chapter 2 here, but I'm going to go to chapter 3. I'm going to expose my application on an HTTPS port and then expose another domain with a different certificate on the same ingress gateway. So let's take a quick look. So for exposing the online boutique store that we just installed on HTTPS port, what we need to do is we need to create some certificates, right? So traffic can only be encrypted with HTTPS if the gateway offers a TLS certificate which the client can verify, and then the handshake will complete and the packets will be encrypted. So for that to work, we need to first create the certificates. So what we are going to do is run this OpenSSL command. This OpenSSL command, like it's explained here, is going to create a root cert, which is then what we're going to use to create a cert for the application. So good, it has created a root key and root cert. Like it says, this is only for demo purposes. In production, you should be using a root cert, or you should be getting your certificates signed by a trusted cert authority, and you should be actually owning the DNS name. Basically, you should have the certificate based on the DNS name of your organization, right, or the DNS that you own. So next up, we're gonna create a private key and CSR, which will be signed by the root CA. So that's this command. So if you look, the first command used the organization and boutique store, and the common name, and the second one uses as marketplace.boutiquestore.com. So the first is the domain or the trust of the organization, and you can think of the second cert as the domain or the trust of the team, which is responsible for this online boutique store application. So now the third command is getting the marketplace.boutiquestore.com certificate signed by the root CA. Let's do that. It says all good. So now, in order to expose this application securely on the internet, we need to configure Istio Ingress Gateway to use this certificates. And the way we do that is create a secret in Kubernetes, which will be based off the key and the cert that we just created, and then configure the gateway to use the secret. So these are the steps to accomplish that. So if you look at this command, it creates the Kubernetes secret called online boutique TLS credentials. And oops, I think I missed. Yeah, there you go. So let me copy this correctly this time. There you go. So it's now creating the Istio system namespace, the online boutique TLS credential certificate, the credential secret, sorry. So if I go into the Istio system namespace and get the secrets, I should be able to see the online boutique TLS credential. Now, the next step is to configuring the Istio gateway to start using it. And that's what the gateway resource does, right? So here is a snippet of a gateway resource that allows us to expose some traffic on port 443 and at the same time use this certificate that we just created. So if you look at this gateway resource, there are 2 or 3 important things. First, it uses the selector Istio ingress gateway. So if we look at our running pod in Istio system namespace, and we look at the labels, oops, that's a lot of labels. Let's do this. There you go. So if you see, the label Istio is set to ingress gateway. So that means this gateway is selecting this pod. The next thing is it's using the port 443. So in this case, it's going to use the protocol HTTPS on port 443 and use the TLS mode simple with this credential name. So using these settings where you have the protocol as HTTPS and you have configured TLS and the reference to a secret, it basically signals the Istio control plane or Istio-D that this gateway should be given, is going to be terminating TLS traffic, and for that it needs to have access to the certificates and keys that are configured in this secret. And then here you also see that I am exposing port 80. This is because I've skipped over the second chapter here in this Twitch stream in which I am exposing the application on port 80. One thing which I skipped over is the host, which is very important. So this host here is called marketplace.boutiquestore.com. This host has to match what is configured in the certificate. So let's quickly apply this resource. Good. Let me see. All right. All right. And then as you will see all along this liveProject, we are going to be using the same resource. What we are going to be, sometimes we are going to be using the same resources and we're going to build on them. So whenever I do that, I give you a nice diff here, which you can use to understand what's the difference between the earlier version and the newer version. These diffs are based on the GitHub repo for the project from where we downloaded the manifest for the online boutique store. So these diffs are with reference to folders there. So once you have downloaded or git cloned that GitHub repo, you can do the diff commands yourself to figure out what's different in the earlier version and the newer version. So then you will see a rather lengthy explanation on each and every field of the gateway resource, which is what I was explaining is different about this liveProject. There are many resources which explain that you can go and copy certain resources to configure certain aspects of Istio in your cluster, but they fail to explain what each of those fields mean or what happens when you change them. So this is the key differentiator and the key value for this project in my view. So it goes over and explains these various things. The next thing you need to configure is use a virtual service with a gateway. And that virtual service is basically going to now route the traffic to the right backend. So in here, the key things are it allows any host. So this is not filtering for any particular host. If you want, you can add a certain qualifier, but we'll do that in the next section of this milestone. But the most important thing is it's going to use the gateway that we just created which was front-end gateway, and then it's going to route all the traffic to the destination front end on port 80. Now, there are a few more things to know about how virtual services work. First is we are creating this virtual service resource in online boutique namespace resource. So that means the actual destination will get the destination that this traffic will be sent to will be front end dot online boutique online dash boutique dot service dot cluster dot local. So the host that the proxy sees is the expanded version of the short name, and the FTDN is derived from the namespace of the virtual service. Secondly, this virtual service is tied to the front-end gateway, like I was saying, and the front-end gateway here, if you see, is also defined in the online boutique namespace. So if you are referring to, if your virtual service is referring to gateways, they should be in the same namespace, or you have to use a different syntax to access cross namespace resources. Another interesting thing that I forgot about the gateway resource is the gateway resource is created in online boutique namespace. It's selecting the Istio ingress gateway selector, and the pod to which the selector maps is an Istio system namespace, right? It's not in the front-end gateway namespace, which is why this configuration will work. And this is why we needed the Kubernetes secret in the Istio system namespace, because pods running in one namespace don't have access to secrets in another namespace. So in this case, the gateway resource lives in online boutique namespace, but it's configuring the ingress gateway pod in Istio system namespace, and it has to access the online boutique TLS credential in Istio system namespace. So these are, again, some of these crucial aspects of configuration that you might miss if you are following Istio docs or certain other online resources, right? So let's go ahead and create this virtual service resource. Good. So now our virtual services is created. So this basically explains how the traffic works and how the different resources work together to send the traffic eventually to the backend. So let's just quickly verify if our HTTPS traffic is working as expected. So what I'm missing here, or what I have done in the earlier sections that I need to do here, is to expose my the Kubernetes service for Istio Ingress Gateway so that I can access it from outside this cluster. And remember, this is a mini kube cluster. What I mean by that is, if I quickly go to the second chapter, it is going to tell me a crucial thing here, which is I have to run a mini kube tunnel command. I have to keep it running in order to make sure that my Istio Ingress Gateway, the service associated with the Istio Ingress Gateway, has an external IP. So let's take a quick look. So right now, if you see, the external IP for my Istio Ingress Gateway service is pending. If I run the mini kube tunnel, and because I have to keep it running, I'm going to run it in a different terminal. So if I run mini kube tunnel, all right. So to make the communication work and to expose the service for Istio Ingress Gateway, I have to run the mini kube tunnel command, which I ran here. And now if I go back and check, I have an external IP for Istio Ingress Gateway. And so this is an important step. So for users or for learners who are taking this project, if the mini kube tunnel command has stopped running or it is not running in the background, make sure you resume it again before you start working on this project. Otherwise, most of the traffic and most of these sections will not work for you. So let me go back to the third milestone and see if my traffic works with encrypted. If my traffic works at port 443 and it is encrypted. So basically what we are going to do is now set this ingress to export variable to the external IP. And then let me go over and check. So at this point, when you're using a browser, your traffic will not work. And the reason is that the SNI host used with the browser won't match the SNI host marketplace.boutiquestore.com, right? So to make sure that the right headers, the right SNI or the server name indication is set in the TLS handshake, we'll have to use curl command or the curl utility, as the browser does not give us the right flexibility to do that. So what I'm going to do is copy this command over here, and first I'm going to set the ingress IP environment variable to ingress here, and then use this command to see if I can get to my application on port 443. There you go. So I have been able to reach marketplace.boutiquestore.com at 443 and the path underscore health Z, but I have done a lot of curl trickery to make this happen. First is I'm making sure I can resolve the marketplace.boutiquestore.com to ingress IP. Since I don't own this domain, I have to resolve it locally. Otherwise, I need to set up DNS and own the domain and stuff like that, which I didn't want to do. And secondly, I'm making sure I'm setting the host header to marketplace.boutiquestore.com and using the CA certificate root.cert that was used to sign the certificate that the ingress gateway is using, right? So these are the nuances that are explained here in details. And other thing is we can use the OpenSSL command to quickly see the kind of certificate that is being offered by the Istio ingress gateway. So if you see here, you will see that the subject of the certificate is marketplace.boutiquestore.com as expected. So good. So now we have encrypted traffic from our user to ingress gateway, and the ingress gateway exposes the online boutique store at port 443. Any user that tries to communicate there without HTTPS, the traffic will be rejected, right? Since it's expecting TLS handshake. So now the thing that we're going to do is expose a second domain at the ingress gateway, which uses a different certificate. So this is a common problem that platform operators often have, right? So you might have different applications which have different DNS names that they all want to be exposed at port 443, and you have to configure the gateway correctly to make sure this can happen. So that's what this section is going to focus on. So just like we did before, we will have to generate certificates for the second domain. So in this case, what I'm going to do is I'm going to expose a domain http://bin@boutiquestore.com, which is going to be used to forward the traffic to a different application, which is http://bin. Instead of creating the certificates manually, in this case, I'm going to use an automated script, which is also available as part of the project GitHub repo. And once I do that, I can follow this command and generate my certificates locally. There, I have created a certificate and the associated keys, and also I have a secret called http://bin TLS credential, which is in the Istio system namespace. Similar to the other secret for online boutique store. So here we have an http://bin TLS credential. Good. So now I'm going to deploy my the http://bin application. I'm going to deploy it in default namespace. I'm going to copy the service and deployment manifest from here. Okay, so now if I look at default namespace, I see that HTTP bin pod is coming up, and we'll wait a few more minutes, and there, it's up and running. So now what we need to do is create a second gateway resource, which is going to be used to expose HTTP bin application. So it's using the same port 443 and the same selector, but it's using a different host here. It's using http://bin.boutiquestore.com and a different credential name. So let's copy this and create the gateway resource. Here I'm explaining the difference between this gateway and the gateway used for online boutique store. Then I need to create another virtual service, and this virtual service will be tied to the HTTP bin gateway and route the traffic coming in based on this host http://bin.boutiquestore.com and send it to the destination HTTP bin service at port 8000. So let's create that. And now my traffic and the configuration looks something like this. Again, this is showing an extra traffic path for port 80, which I have skipped over for this a Twitch stream. But if you're taking the project sequentially, you will see all the different paths. So now what I can do is I can use the HTTP bin.boutique store host and get to HTTP bin application, and my online boutique store should still continue to function at the other, if I use the marketplace.boutiquestore.com, right? So this is the benefit you get from Istio service mesh and the Istio Ingress Gateway, where you can have these composable resources and you can have the same pod, the same workload, but you can create two gateway resources with different hosts and different certificates, and the gateway will be used to terminate traffic and offer different certificates depending on what SNI is requested by the user. So that's it. So this is what I wanted to cover in details for this stream. I hope you all take a look at the live project and get benefit from it. And if there is any feedback for me, I'm happy to hear. You can use the Manning tools to send me feedback or reach out to me on Twitter or Istio Slack. I am available as NRJ Poddar. Thank you for joining me.